Welcome to Science Made Easy channel. Last week we looked at measurement and I gave you some assignment. Today we want to look at solution to that questions. And these are the questions. One was, say, show by working the SI derived units of the following quantities. The first question under this question was I, area, volume, 3, density, 4, speed, 5, velocity, 6, acceleration, 7 was force, 8, work, 9 was power, and lastly, which was the 10, pressure. Now let's find answers or see how we can show working by finding the derived unit of these quantities. To find the solution, we need to bear in mind with these principles you're going to use. The first principle about indices says that any number written without an index can be written with the power 1. For example, 7 can be written as 7 to the power 1, or 7 raised to the power 1, or 7 index 1. If it's an alphabet, for example, L can be written as L to the power 1. L to the power 1. In the second law, so the first law of indices also says that to multiply numbers written with the same base, add the powers. For example, you have a to the power m times a to the power n. Because they have in common base a, we just write only one of the a's. Then we add the powers. So you get a to the power m plus n. Hope it's clear now. So based on this, let's look at our first solution, area. What is the formula for finding area? Yes, area is equals to length times breadth, or length times width, or length times length. So we are using length times length. We are assuming that the object is having a square shape. Length times length. The first principle we started with said if a number is written without an index, then it can be written with the power 1. So length, having the symbol L, is not having any power, so it can be written as length to the power 1, or L to the power 1, times length to the power 1, or L to the power 1. So simply we can have, because having common base, we write only one of them, L raised to the power 1 plus 1. Good. What's the SI unit for finding length? Good, meter. So you can recall that last week we learned that the base unit to the base quantity length is what? Meter. So if SI unit of length is meter, then we can have the unit of area as meter times meter. And we are using the symbol m for meter. So with the first law of indices, then we can have meter to the power 1 times meter to the power 1. In other words, m to the power 1 plus 1. Then you have what? M to the power 2, or meter square. So the SI unit for area is equals to what? Meter square, or M with the symbol M to the power 2. Solution number 2, volume. What is the formula for finding volume? Good. Volume is having the formula length times length times length, or length times height times breadth, or length times height times width. And length times length times length, we can have the length to the power what? 3, or length cube, or cubic length, if you combine the two principles we just considered in our first solution. We have also learned that the SI unit for length is what? Meter. So in this case, the SI unit for volume will be what? Length is meter, so we will get meter times meter times meter. And we said let's use the symbol for meter as M. So having a common base, we write one of the M, meter, to the power 1 plus 1 plus 1. So we will get meter to the power 3, or M to the power 3, which is simply called cubic meter, or meter cube. Meter cube. Our next one is density. Question 3, density. You know the formula for finding density is mass over volume. Mass over volume. We learned last week that the unit for base quantity, mass, is kilogram. Kilogram is the base unit to a base quantity, mass, and its symbol is what? kg. Then we have just learned how to find the derived unit for a derived quantity, volume, that its unit is what? Cubic meter, or meter cube, and it have the symbol m to the power 3. So we have the SI unit for density as kilogram over meter cube, or cubic meter, and their symbol, we will get kg divided by m to the power 3. So writing this will be so simple. We'll get the SI unit for density as kilogram per meter cube. Kg slash m to the power 3, or kg m to the power minus 3. Good. Our fourth example, which is speed. How can you determine the speed? Meaning, what is the formula for finding speed? Speed is equals distance over time. Distance is length. Then time can also be measured with the stopwatch. So distance is length. So if distance is length, then what is the unit for length? Is meter. The unit for time is second. So you will get the SI unit for speed as what? Meter per second, or meter divided by second, having the symbol meter as m, then the second as what? S. So meter per second, or m/s, or ms to the power -1. That's the second law of indices. You can go and refresh your mind about it. Now let's go to the fifth one, which is velocity. What is the velocity? Velocity can also be found using the formula displacement over time. Displacement is also equal to length. Just that this distance is having a direction. So displacement can be equal to what? Length. So if displacement can be equal to length, then we know that the unit of length is meter. Then velocity will be equals to the SI unit of velocity will be meter divided by seconds. Meter having a symbol m and a second having a symbol s. So the SI unit for velocity will be meter per second. The same as what? The speed. But the difference between the speed and the velocity is that velocity is having a direction. Sixth is the acceleration. And the formula for finding acceleration is change in velocity over time. Change in velocity over time. We already know the unit for velocity. We said it is meter per second. And time, its unit is what? Second. So the SI unit for acceleration will be meter per second, or meter divided by second divided by second. And this will give you meter over second times the division. Reciprocal of it will be multiplication. So times 1 over second. And this will help us to get meter over second square. So the second times second, s times s will give you what? S squared. Having a common base, so you write s, then the powers, you add them. 1 plus 1, you get s to the power 2. So the SI unit for acceleration is what? Meter per second square. Meter per second square. Good. Then we have the seventh one, which is force. Force, its formula for finding force is mass times acceleration. It said the unit of mass is a kilogram. And we just learned that the unit of acceleration is what? Meter per second square. So kilogram times meter per second square will give you the unit of force. So the SI unit of force is what? Kilogram meter per second square. That is kilogram times meter per second square. And this symbol will be kg m/s to the power 2. And this is equivalent to Newton. So kilogram meter per second square is equivalent to Newton. So Newton is equals kilogram meter per second square. When we look into details, especially when it comes to force. The eight examples, our eighth solution is work. And work, formula for finding work is force times distance. Force times distance. And force times distance you will get force. You have learned that it is Newton or kilogram meter per second square. And we said distance can be equated to length, and length, its SI unit is what? Meter. So this we will get what? Newton meter. So the SI unit of force is what? Newton meter. Newton meter, which is also equivalent to joule, the symbol J. So 1 joule is equivalent to 1 Newton meter. Ninth is power. Power is work done over time. We just find the SI unit of work. We said its unit is what? Joule or Newton meter. And we already know the SI unit for time, which is second. So power, the SI unit of power is joule divided by time, which is second. So we have joule divided by second. Joule divided by second. So we have joule per second as the SI unit of power, and it is equivalent to watts. So 1 watt is equivalent to joule per second, J/S. The symbol for watt is W. Then the last one, the 10th one, what is pressure? Pressure is force over area. We said force is what? Newton. Area is what? Meter square. And this will give us our unit. Force, we already know it is Newton. Area is meter square. So we get Newton per meter square. Newton per meter square. Or Pascal. Or Pascal. So this is where we end our lesson for today. You have seen how we can show working for various derived quantities in their units.